Okay, I would like to talk about electronics and textiles. I call it e-textiles, also called intelligent textiles, in the scope of Philips. And what we always have envisioned is that somewhere in time the world of electronics, so we come from electronics as Philips, but maybe the world of electronics will be freed from the rigid encapsulation as it is at the moment. So every electronic part is now sold in plastic boxes, in hard stuff, in hard boxes, in plastic metals. But maybe in the future it will be freed from the rigid confining encapsulation and integrated in the fiber of our daily lives, so that it is all around us and distributed and give a very ambient, pleasant environment. So that's our dream, to make electronics like that. And I would like to sketch what we do in this field by 4 parts. So first I would like to look a little bit to our company, Philips Lighting, which is in transition. And then I will switch over to what we did as Philips with textiles. And third, a particular project. And then some conclusions for conformable light for architecture, which is maybe more dedicated for this audience. So at Philips, we have a goal, and that's to improve the lives of all 3 billion people per year in 2025. So that's our goal, and this is also a very serious goal, because we count every improved life, and 3 billion is a lot, but we have to work for that. And we do that by healthcare, to create good healthcare. We do that also with consumer electronics, and we do that with lighting. And I will focus on the lighting part today. So if you see what's happening in the world, then you see some mega trends. You see that the world is changing, and that we grow as world population, so we need at least more light. As we heard before, also in third world countries, there's a lot of demand for light, and we would like to provide that. And that light should be efficient, so we should not build too much power plants for that. And we see also opportunities for integrating digital information into the light production. I come back to that. So if you see what's happening with light, then we come from an area where every light was made from incandescent, high energy consuming light bulbs. And even in 2012, it was about 82% of the world market was invested in that kind of light fixtures. And we see at this moment, so 2015, 2016, that more than half of light is LED lighting. So LED lighting is really taking over from the conventional lighting sources. And that's a big revolution. And LED lighting makes it also very easy to make digital information connected to that light. So what we see is that we not can only provide light sources, but that there is a full digital value chain possible. So we can not only deliver the light source itself, but also the software, the controls, and then specific luminaires, and maybe textiles plays a role over there, and also the smaller details of the light bulb. So everything is also covered by our company, but what is interesting is that software and controls really come in. So we do that at Philips with a 4-pillar strategy, and it is about those pillars, but I come back to everyone. So first it's about the technological revolution. So we see that LED lighting will be more efficient and more smaller and more powerful. So we can provide now 200 lumens for 1 watt. It's really a breakthrough. We can really control the light colors, and we make very unique styles which are very nice to integrate in luminaires, for example. So we are a leader in LED as a company. But we do that technology, we bring that also to the consumer. So here we are in the consumer market, where you see that we have particular solutions, for example in children's rooms, and with Disney lamps and that kind of ideas which are really attractive for consumers. And we do that also, for example, in the professional space. And then you see that also in the outdoor, a lot of light is produced by Philips. So big projects on streets, in cities. And yeah, this is the other pillar is about connected lighting. And I try to open this video. I hope it will open. Okay. I think I have to skip it. I will skip this one in due of time. But we have very interesting material on how we would like to connect our lighting systems with the activities we do at home or at offices. So one of the architectural highlights at the moment is that we built a new building together with Deloitte and Touch in Amsterdam. It's called the Edge, the building. And all the light is connected in this building. All light has an IP address so that we can control every single light point in it. And the lights are also powered by that network. So it gives a very efficient light effect in the building. So every area in the building can be tuned to the demand over there. But it gives also opportunity to do the other management of the facilities. So for example, temperature in the rooms. That kind of information is also collected by sensors which are in the lamps. So you can control the complete building by the light infrastructure. And that reduces the infrastructural cost of this kind of building. So that's really for architects also maybe very interesting idea how to construct buildings around light. So that was what we do in a professional commercial way, and now I will switch over to what we did with textiles. So it's a kind of different topic, but it comes back to the architecture later. So we have a very long history in working with textiles at Philips. We started, I think, 15 years, 20 years ago already, with a lot of design tests to bring textiles and electronics together. So we made several things and showed that to public. We did that first as a design community, but later we really brought also these products into the market. So above the arrow we have our commercial activities, and below we have our design activities. But I come back to some of them in the next slides. For example, one of the design activities that we made a dress with LED lights and the bubble dress, and that was presented to the public in 2006. There was also interaction in that, and at that time LEDs were really new, and it took a lot of attention. So for us was a reason to continue with the field of integrating LEDs and textiles. So it was really appreciated by the upcoming internet, and people really were in love with this kind of technologies. And so we took that idea from design, we took that into the commercial phase of Philips. So we made a project, and we called that Philips Lumilife, where we took that LED lights out of the dress but put it in the t-shirt and made a kind of LED displays out of that. And with those displays you can express yourself, and we sold those t-shirts in the event and exhibition market, where people were using those t-shirts to give messages to public, for example. And it was maybe at that time very revolutionary product. Took also a lot of attention on the internet, but it was maybe a little bit too expensive to build. It's almost 10 years ago. At that time, LEDs were still at a reasonable high price. But here you see what we did also with if you bring a group of people together and give them all that kind of t-shirts, you can give also a kind of group identity and have some synchronization between t-shirts. You can really make nice shows. So that was for us a very nice learning point, how to deal with textiles and how to deal with fashion also. And a lot of artists thought about that as well, and they all liked that idea, and they came with special requests. So we did For example, with Michael Jackson we did a project. We did also a project with Black Eyed Peas where we tested how LEDs and OLEDs could work together with wearables. And it's not so easy, we learned, because there are so many differences in the way electronics are from textiles. I'll come back to that. But we still continue. For example, this design, this shirt, this jacket is designed by Koen van Dongen, I think in 2012. We still try to use LED effects and clothes in order to express yourself at dark environments. Normally, clothes are bought because they look nice and they give the brand, they give you an image. But as soon as the environment gets dark, yeah, you get lost of that image. And maybe by the help of some light, some LED light, maybe this expression can continue during the nightlife. And maybe it's also a little bit about safety, but at least it is also about expression. So that is still an area where we are looking to cooperation with people who can help us there, because it's a very difficult topic. In the meantime, we thought about how to go a little bit fast, because doing fashion and that wearable is maybe a little bit too slow, because people really have to adapt to that. But maybe we can go faster if we bring this textile and LED technology in another area, for example in the office area. And let's make light-emitting wall panels, and we call that large luminous surfaces. There's also one example here in the exhibition. So that is an acoustic panel which you can integrate in your architectural design, and where dynamic light effects, low pixel, so it's not a TV display, it's a kind of environmental lighting display, so it gives you just an atmosphere, not really a message. But the ambient atmosphere can be created by these panels, and they can be all over the place. So they can be, the full walls can be covered with that, and this gives a very interesting environment. And this is done together with a company Quadraat. That's a Danish company. They provide high quality textiles, and we provide the lighting fixtures, and together this forms the product. So we really look to cooperation also with this kind of companies, because we are not a textile company, and the final touch is in the quality of textiles. You see another example of what we do with the large luminous surfaces, and you see that it's also about not only see, but it's also about touch, and it's about sound, so the acoustic absorption, and it's about connectivity. So you have to upload the content of the movies, so the low pixel movies. You can do it digital and very easy way, but that is very necessary to be very easy to use by people who own this products. So it's not only the lamp you have to make, but also the full infrastructure around it. The same we do with what we call luminous carpets. So we produce together with Desso. Desso is a carpet manufacturer from the Netherlands. We make light effects in the carpets. And here you see the same procedure. We work together with Desso, and we do light effects by Philips, and we create also the infrastructure around it. So it's not only the material, but it is also the carpet, the light source, the controls, the user interface, and the installation. So it's a bunch of activities you have to do to make this service to your customer. So you see that it is really moving into the direction of providing more digital information, more solutions than just the material. And now I come to my project where I worked on the last couple of years, and it was called Place It. And that was really a research project where we worked together with European companies to see how we can make a step further in the integration of textiles and optoelectronics, so light emitting electronics. And the idea was that the current electronics were all rigid, all in boxes, and you see some examples already in the market where electronics are quite flexible. So flexible means you can roll it up. And our idea was that we have to go a next step into what we call conformable. Because if you do only flexible electronics, then you do it only for manufacturing. It's easy to manufacture, it's easy to transport, logistics is easier. So making large LED strips is all done on rolls, but that's because of manufacturing and logistics. But the wearable comfort or the usable comfort comes from another step, from the conformable electronics. And we still have to make that step. So that it is easy to wear. So that's not for architect, but it's for fashion, for example. But it gives some benefits for the architectural ideas. I come back to that. So we used here in this project, we used the textiles because of the qualities of textiles. So you see that textiles are always conformable, breathable, lightweight and robust. And also the nice effect, textiles are relatively cheap, so they can be produced in high speed. And you can also choose materials which are quite sustainable. So if you look to what we do in conventional electronics, it's all about plastics and metals. Yeah, textiles can be maybe a natural source, can be maybe a better source for building big things. And we can do two directions with it. We can go to wearable electronics, and we can go into large area electronics. Comfortable wearable on the body things, or large area, maybe architectural devices. And we work together with a lot of companies. So it goes from automotive companies like Automotive Freudenberg or Grupo Antolin in Spain, but also with medical companies for the wearable stuff in Mannheim. Also textile companies like TITV, Omatex and Centex Bell from Denmark, Germany and Belgium. And we brought a lot of knowledge together. And we started in 2 years to build a lot of building blocks. Then we started integrating the things, and then we came up with some demonstrators, and it was about automotive demonstrators, medical and phototherapy. But there was also room for discussion on light for architecture. It was really also in the scope of this project. And so we started with the building blocks. That's a very technical start. So we started with weaving and with knitting. We used the conductive wires to big rolls of material. And with those rolls of material, we mounted the LEDs. So that was the basic component. We thought we could make all those things. And with those things, we made this product. We call that a phototherapy device, a blue lamp, which was flexible, bendable, conformable to the body. And this blue lamp can heat up your back. And with this heat, and also with the blue light, you really can heal your back pains. So it's a medical device. And it's also in the shop nowadays. It's called the Blue Touch product. And with this Blue Touch product, you can heal your back pains by the unique blue light. And the unique blue light has to go really smooth on the skin, otherwise it doesn't work. And for that smooth contact with the skin, we needed the textiles. And with this project was perfect solution for that. And nowadays you see that this blue light is also, it started from our textile exploration, and it went to the back pain, and now we do the same idea, blue light, but now we can also use it for healing psoriasis. Psoriasis is one of the nasty diseases which cannot be treated in a natural way, but with blue light we have a solution, and it can compete with a lot of medicines which are also not so nice. It's a revolutionary product, and it really comes out of thinking about textiles. What we learned is that we can integrate our technology in all levels of the supply chain of textiles. We can integrate it in yarns, or we can integrate it in fabrics, or we can integrate it onto the fabric, or we can just create pockets on garments where we put our electronics inside. And we thought about all the levels, and we made some conclusions, but I think the integration at the last part of the supply chain, so really bringing the electronics together in the pockets of garments or in the pockets of a carpet, so to say, is the easiest way to go for commercialization. Because when you do it like that, so keep it as separated as possible. So keep your textiles, electronics, you have the freedom of personalization. And I think this picture gives a good example for that. You can always choose your own jeans and always choose your own phone, and don't have to make decisions on that. It's also most reliable solution, and it is also managing the mismatches in industries. Industries don't have to talk with each other because that seems to be very important, difficult. Electronic textiles industry cannot talk together. It's a lesson we learned in the past. And maybe also a sustainable solution, because if your jeans is gone, you still can use your phone. And the consumer understands, they know there are different products, so easy to remove before washing. It's always a big issue. Here you see that there's a mismatch with electronics and textiles, so the jeans with holes in it is maybe modern, a hole on your iPhone is not appreciated. And yeah, how to, we have not an answer to that from electronic point of view. We cannot make unbreakable electronics in that sense. Okay, now switch to the last part. It's about conformable light for architecture. This picture I took at a market in Palma de Mallorca this Christmas, and then you see that conformable light, so light which is stretchy, which is hanging, which is just easy to roll up and to bring in the shape you want, is already there. It's the Christmas light you see everywhere. So, okay, 5. The Christmas lighting which is used here at Palma de Mallorca is just, you see it everywhere in Spain and maybe also other places. But it can fulfill the function. But my question is, what if we add textiles to this? Maybe it becomes not even Christmas light, because maybe you can use it all year long. So that's for lighting. The question is not so much on how to make the lighting. The question is more how to make the interesting textiles which can be around this kind of lighting devices. And one of the investigations we did in this field is that we worked together with Astrid Modi. She's a PhD student from Denmark. We made a project, textilization of light, and that is also here in the exposition. So we try to use to make building blocks, kind of Lego building blocks which click together, and create a kind of network of light, and every light point could be operated separately. And then you can create also three-dimensional spatial areas. And the idea was that at the moment we started this project, there is a lot of display technology available. So you see all displays on the facades of buildings, which are very static, very two-dimensional, very not so nice, not so appreciated, but of course they give a lot of information, a lot of digital information. But what to do if we bring this kind of devices in a more spatial and more living 3D device? Maybe that becomes much more interesting to be applied for architecture. So that's the reason why we built this this device, and it is still under investigation how to continue with that. But at least it gives the first steps in that direction. So here you see what we did in Copenhagen, and it is a light, it's an LED display where you can walk through, and it is also quite robust because there's some stretch in it. If you put on it, it doesn't fall apart. It is completely a kind of spring, and gives a robustness, and also wind and environment could be exposed to that. So I would like to close this talk with a summary, so that the world needs more light, more efficient light, and more digital light, and that we need that we do have an area of verification and digitization, connected light, value creation beyond illumination, not only making the lamp, but the value of the full system is very important. That e-textiles from Philips were an enabler for many products in the past and will be in the future as well. So we really look into textiles. And conformable electronics, conformable lighting sources are maybe very interesting for architectural applications. Acknowledgements to the Astrid Modi, PhD student, the Placed project, Philips Glass luminous surfaces, luminous carpets, and Pauline van Dongen, who contributed to this presentation. So, our ambition, enhancing life with light.
Thank
Thank
you.
you.
A couple brief questions. The audience. Yes, please. Could you use the microphone because people behind you have a hard time hearing?
Thank you. I was wondering, you say we need more light, but I also think we need more darkness. Does Philips also think about that? How to also create darkness?
Go out of business.
No, we made the switch. No, not joke. Yeah, but it's a very good question. The effect, yeah, we spoil a lot of light. But if you look to efficiency of light, the most efficient light is a dedicated light. So if you make light which is dedicated to the task or the place or the area where you want to be or where light is needed, then it's more efficient. By that, by making more dedicated light, you create also more darkness. So for me, for example, the idea of light enclosed on the road is maybe at the moment not the big demand, because at the moment there is so much light spoiled by the environment. But as soon as the car lights are only lighting up the streets, the shop lights are only lighting up the shop windows. If every spoiled light is away, the humans on the streets will be very, very dark. And maybe then it's very interesting to have light in your clothes in order to be visible. And because the environment is dark, you don't need too much. A little bit of light is enough because it's dark enough to see you. And with this little bit, it's also easy to manage because if the batteries are not too heavy or last long. And then you have a complete different street view where darkness is an important role. So maybe we should create darkness in order to make light.
You got out of that pretty well, eh?
Yeah.
Anyone else? I have two questions for you, Koen. That exhibition that you showed, was that at the architectural office of Let and Gori?
Yeah.
I saw it.
Yeah?
I'm amazed. Yes.
Yes?
Yeah.
Okay.
I interviewed them for Architectural Record last summer, and the show was up when I was there. I had no idea.
Okay, yeah, it was the same. Yeah.
Okay. My question is, and after that we'll move on to our final speaker and then to our discussion. Maybe this is something I'd like to come back to in our discussion. Who is pushing and who is pulling? If I hear you, it sounds like the industry is pushing. If I hear some of our other speakers, it sounds like the designers are pushing. Who is in the lead? Who's following? Where is innovation actually coming from?
Oh, I hope from the discussion. Now, pushing should be not the right thing. We are blamed for pushing technology in the past. As Philips, people say you push too much and therefore you were not successful enough. But we're still there. But on the other hand, yeah, the demand of the customer is not coming automatically. People will not stand up and say, I need clothes with lighting or I need architecture with lighting. So we have to show it a little bit and have the discussion and create some demands and some first demands, and then, yeah, let's make a seed and let it grow somewhere. So it starts probably very small.
And who's the first person to think about having lights in your clothes, other than the fluorescent strips that runners have? But like Pauline van Dongen, did she come to you with this idea, or did you go to her with this idea?
No, see, that community comes to us. Yeah, yeah. We got a lot of questions like that in the past, and it's still coming. Yeah, absolutely.
Okay.
Yeah.
Oh.
And that's fashion. Fashion is maybe in some areas also close to interior, because that's also something changing over time. But people have more ideas about how to pronounce that correctly. But somewhere also interiors are a little bit fashion, and maybe light in interiors can be also, yeah, a sustainable part of that in the future.
Okay.
Yeah.
Thank you very much.
Yeah.
Koen van Ons.